welcome to our YouTube channel. Today we are going to talk about yet another interesting topic of our addition reactions in organic molecules. Now, organic molecules undergo addition reactions, and there are two types of addition reactions where we have got electrophilic addition reaction or nucleophilic addition reaction. So as an example, we have got this alkene which undergoes an addition reaction to form a substituted alkane. So basically, this is an example of an addition reaction where two reactants make one product. So they add up to form this one product. And today we are going to dwell much on our alkenes and alkynes where they undergo electrophilic addition reaction. So we're going to talk of the general equation of an electrophilic addition reaction. This is the general equation of an electrophilic addition reaction where we have got here our multiple bond and our highly polarized atom to form a saturated addition compound. So what generally happens is these double bond or multiple bond interacts with this to form this. So we are going to talk more of what really happens in electrophilic addition reaction in the reaction mechanism below. So these are the common atoms that can be added to an alkene or alkane. So as you can see, all these atoms, we have got one or more electronegative atoms. That makes the compound highly polarized, and thus it results to be an electrophile. As you can see here, we have got our H2O where we have got our hydrogen, and there is our oxygen. So this oxygen is highly electronegative and can pull away electrons from our hydrogen, as we shall see in our reaction mechanism of both our HX, and our X2, and our H2. So as for our mechanism of action of electrophilic addition, we've got this is the mechanism of action. So what happens in our mechanism of action? This molecule is highly polarized because at one end we've got a high electronegative atom that pulls away electrons to itself away from the hydrogen molecule. So this hydrogen molecule, this end here, becomes partially positively charged and it becomes electrophilic. So this CC double bond is very rich in electrons. So this one is attracted to this CC double bond in such a way that it gains some electrons, and this causes the breakage of this CC double bond, as in this case. So we are here, and the H molecule forms a bond with this carbon, with one of the carbon molecules, and one of the carbon molecules is left with partially a positive charge. So this then electronegative ion is rich in electrons, so it has got a partial negative charge, so it goes on to bond with this atom. So the result is this saturated addition compound or product. So this is the basic mechanism of electrophilic addition reaction. So the most important parts are our double bond and this polarization of our HX atom, which then leaves one end with a partial positive charge, which then helps it to be attracted to the double bond and forms a bond with one of the carbon, and the other carbon is left with less of a negative charge and becomes partially positive charge, so that this molecule that was left here will then have to be bonded to this carbon plus molecule. So we've got our examples for addition reactions here, and the first example here we've got an alkene molecule where a hydrobromine is being added to the alkene molecule to form this. There is where the mechanicals rule comes into play. We'll talk about the mechanicals rule in our next video. And there is the alkyne being added, and the bromine molecule being added to the alkyne to form these two, and these two molecules, cis trans molecules. We've got 1.2 dibromobutene. So thank you. This is it. We've come to the end of our presentation. Don't forget to like, share, and subscribe to our YouTube channel.